Oh, but I've heard about this thing called text pattern ops. And if I use it, it's supposed to help me with text searches. So what does that get me?
Yay, problem solved.
Not.
Oh.
So, so line 1, I created a new index that's using this different, essentially, operator, because by default, the Btree operator works well in an equality mode, or greater than, or less than, or equal, greater than or equal to, etc. It works great for that. But if you actually want to look through text and look through it a character at a time, so you're not looking for an exact search like I did previously, but you want to look at a character at a time, you need to use this different operator. So, and it depends upon your data type that you're using. So if you're using the text data type, it's text pattern ops. If you're using the char or the char, however you want to pronounce it, that's the char pattern ops. Now, the caveats with using this, the first caveat on line 3 is that it only does left anchored searches. So again, if you think back to using an index, by left anchored, I mean, it's going to check the first letter first and then the second letter. That's how you get fast text searches, is it needs to be left anchored if you want to use this. So you can use a Btree index, but you can only search through the left portions first. And the second thing, you cannot use I-like in this condition, because it's kind of looking for an exact text match. Now, you may be able to finagle it and do, like, use a functional index, like maybe use lower. So you build the index as a lower of the title with text pattern ops. That's possible. I don't have an example of that here, but that may work to give you a case insensitive way to search it. But well, I'm just saying, you could, if you want to do it, that may be another path.
Yeah, but who wants to do that?
Look at the search results here, man. We'll get to that. Look, TLDR, 430 milliseconds for a search versus 0.033 milliseconds for a search.
Okay, that's slightly better.
So if you look at number 6, that's the same query as before. Even adding that text pattern ops, you can still see it's doing that parallel index scans, scanning through all the values. That doesn't speed things up. Even if I do a left anchored, meaning I'm only looking for, some value and then a wildcard at the end, it's not going to work, because there are, we're doing an I-like. But in line 22, when I change it to a like, and I happen to use, it's whatever the text value is. Presumably, if a blog post starts with Apple, you're going to have a capital there, but you have to basically match whatever case it is. And as you can see in this case, now you're no longer doing a parallel scan. It's doing a scan against a particular index condition, and it gives you a performance of, as you can see here,
So you can use an I-like with this. It's not like it'll throw an error. It just isn't going to help you at all.
It's not going to use the index. Yeah. So when I say you can't use it, basically, if you give it that query, it's not going to use the index.
Okay.
But a way you might be able to get around that is, like, build an index that is lower, uses a lower function to lowercase all the values.
Right.
But that means every time you query, you got to do, like, lower Apple %,
Okay.
All right. But this doesn't help us if we're looking for a value in the text. So let's go to the next slide. If you like this clip and want to watch another one, you can click right here. Or if you want to watch the full video, you can click here.